Good afternoon, everyone. I'm sure Dr. VanderWeele needs no introduction, but I'm still going to share his bio anyway. Dr. VanderWeele is the John L. Loeb and Francis Lehman Loeb Professor of Epidemiology in the Departments of Epidemiology and Biostatistics at the Harvard T.H. Chan School of Public Health, the Director of the Human Flourishing Program, and also the Co-Director of the Initiative on Health, Religion, and Spirituality at Harvard University. He has degrees from Oxford, University of Pennsylvania, and Harvard University of Mathematics, Philosophy, Theology, Finance, and Biostatistics. His methodological research is focused on the theory and methods for causal inference in the biomedical and social sciences, and more recently, psychosocial measurement theory. His research is very broad, spanning from the science of happiness and flourishing to the study of religion and health. He's received the 2017 President's Awards from the Committee of Presidents of Statistical Societies. He's published 400 papers in peer-reviewed journals and is the author of several books in causal inference, epidemiology, and also well-being, and runs a blog on Psychology Today. So it's with great honor that I introduce Dr. VanderWeele, who will today be discussing some of his recent work on psychosocial measurement theory titled Constructed Measures and Causal Inference Towards a New Model of Measurement. And I would like to ask if possible to hold your questions until the end so that we can have time for discussion. Thank you very much. Tyler, you can go ahead and take it away.
Thank you for the kind introduction, John, and thank you all for coming. It really is a pleasure being here to share a bit of my recent work and thinking on this question of measurement. And it was the work on well-being that essentially moved me in this direction. Most of my methodologic research had been on causal inference from observational studies, but as I was approaching questions of how do we actually go about measuring something like purpose in life or character, I started engaging more and more with the psychometric literature on measurement, trying to learn from it and try to use it to inform the development of better measures. And as I went through that process of engagement, felt that questions of causation seemed to have been neglected in much of the work on measurement and measure construction, measure evaluation. And so I've shifted my own methodologic work to this question of measure development and evaluation, trying to bring in perspectives from causal inference. I'll be sharing some of that with you today. A disclaimer, I do very much view myself as a novice in this field. The literature in psychometric measurement theory is vast, and I know I've only digested a small portion of it. So the insights and thoughts from all of you would be much appreciated, and apologies in advance for what I get wrong or misconstrue. But I do think causal inference as a discipline has quite a bit to contribute to this process of measure development. So I'll make some remarks on measurement and factor models. I'll then present a formal test to essentially reject the model which I think is most commonly used in thinking about measurement. And I'll give some examples of this. I'll also talk about what happens to factor analyses when supposed factors potentially causally affect one another, and how this can also, I think, complicate interpretation of factor analyses. I'll present an alternative causal interpretation of associations that one might get from between a constructed measure and various outcomes using causal inference theory concerning multiple versions of treatment, and then kind of provide a sketch of a new model for thinking about measures and measure development. The three papers here are sort of my initial foray into this topic, one of which was published, two of which have been reviewed and are in the process of revision. Those are available on archive as well, or from my website. And again, critiques and comments most welcome either at the end of this time or feel free to drop me an email. But no, in the biomedical sciences, at least, often we're looking at objective features of the observable world: weight, blood pressure, age, We might be concerned about measurement error or the accuracy of our instruments, but usually we do have precise definitions. But things become a whole lot more complex when we move towards psychological or social constructs, as with the work started on well-being, or with things like depression or intelligence or socioeconomic status or social integration. Here, we're also worried about definitions, about the conceptualization of what it is we're talking about, and not just about the mechanics of measurement. What often happens in practice is that measurement takes place indirectly through a series of indicators, and then the kind of the selection and the categorization of these indicators is really a major task of measure construction. And there are various practices that have been developed and are employed, often involving factor analyses, but other metrics like alpha. But once the indicators have been selected, it's often assumed that there's some sort of univariate underlying latent variable or construct that itself gives rise to the indicators. And often with measure construction, we're kind of looking for evidence of unidimensionality of the indicators. If we have a bunch of measures of depression or of happiness, then we kind of hope that there's a single unidimensional latent variable that's giving rise to our indicators. So we look for evidence for that unidimensionality. We then typically assume that there's some sort of underlying univariate latent variable. We sum our indicators as assessment of that supposedly unidimensional construct, and then view the interpretation of our results as relatively straightforward, because there's a univariate latent variable underlying this. We may correct for measurement error, but this is the effect then of that latent variable on our outcome. And so there's discussion as to what model really is appropriate. Maybe this varies by context. The reflective model, which I think is sort of more dominant, again assumes that there's a univariate latent that gives rise to the indicators. But sometimes it seems more appropriate to use what might be sometimes called a formative model, where the indicators themselves are sort of affecting, giving rise to our univariate construct. So something like social integration is perhaps viewed more appropriately as a result of a formative model. We have different things like marital status or time spent in community groups or whatnot, and that gives rise to social integration. But in most of this work, not all, but in much of this work, we assume there's kind of an underlying causally efficacious univariate latent variable, eta. And so in this talk, I'd like to challenge the notion of an underlying unidimensional construct, challenge also the evidence that factor analysis supposedly gives us for unidimensional constructs, and actually for conceptual relations at all, as I'll be discussing in due course, and then propose an alternative causal interpretation of regression analyses when we construct measures that's applicable even if the underlying construct's not unidimensional. And sort of sketch a process then for measure development. So again, often we're looking for evidence that our series of indicators is explained by an underlying univariate latent variable. But I mean, even if that is the case, the exact interpretation of that latent variable, I think, is often ambiguous, and ambiguous in a way that is not often explicitly addressed. So I'm going to distinguish between what I'm going to call a statistical factor versus a structural factor. So if we have a latent variable eta and a series of indicators x1 through xn, and say each indicator is given as a function of that underlying latent plus error, then we'll say it is a statistical factor if that equation holds, if the statistical relations are described by that model. But often what's then assumed is that eta really exists in some sort of structural sense, such that it's eta itself that's causally efficacious, and the indicators really are just imprecise measurements of that underlying real univariate latent variable eta. And there's really nothing in the statistical model that indicates that that's necessarily the case. The statistical model itself is consistent with eta being causally efficacious for our outcome y, say. But the statistical model is also entirely consistent with the possibilities that the indicators themselves are what's causally efficacious. There's nothing in the statistical model that says this causal diagram, the first causal diagram's right and the second is wrong. And so when it's really the underlying latent variable eta that's causally efficacious, I'm going to call that a structural factor. So I'm going to say that basic statistical factor model is structural if the indicators themselves do not have any causal effects on anything subsequent, and moreover, if they're only affected by antecedents through the latent variable eta. So you can only affect the indicators through eta. Eta's only, the indicators themselves are only related to subsequent outcomes through eta. Eta is really the structural variable here. So in terms of formalizing this, if one were to use causal diagrams on a causal diagram, a factor eta with indicators x1 through xn would be structural if there were no arrows directly out of x1 through xn, and also no arrows into x1 through xn except from eta. So, or possibly if the error terms for x1 through xn are correlated in models that allow for those. If one interprets a causal diagram as a system of non-parametric structural equations as per Pearl, then that structural assumption is equivalent to, for all variables z on the graph, z is independent of x1 through xn conditional on eta. Once we know eta, that characterizes entirely the relationship between our indicators and everything else, because again, it's eta that's giving rise to these imprecise indicators of our underlying structural variable. And this is, I think, effectively what's presupposed by most structural equation models with latent variables. Now, it turns out that assumption, which I think is often implicit, usually not explicitly stated, but is often implicit in a lot of the work that is carried out, it turns out that assumption of a structural factor is so strong that it has empirically testable implications, even though we never observe the latent eta, even though eta is unobserved. So one can show that if z is independent of x1 through xn, our indicators, conditional on eta, in other words, if eta is structural, if x1 through xn only have causal relations with other variables through eta, if that's the case, and that basic statistical factor model holds, then one can show for any I and any j, essentially any two indicators and any value of z, that the average value of indicator j conditional on z must be related to the average value of another indicator I conditional on z by the factor loading. So there needs to be a proportionality between those expectations and the factor loadings lambda I. So that's kind of the general result, but intuition is perhaps a little bit more accessible through various corollaries of this. So let's say we have a randomized treatment, T, and we were to look at the effects of T on each of the indicators. If eta really is structural, so that the indicators can only be affected by the treatment, by the intervention through eta, then the effect of the treatment on indicator J has to be proportionate to the effect of the treatment on indicator I by those proportionate in accordance with the factor loadings themselves. If we take the effect of T on indicator J and divide it by lambda J, we need to get the exact same thing as the effect of treatment on indicator I divided by lambda I. And again, that's because the treatment is supposedly only affecting the indicators through that structural variable eta. Likewise, similar results pertain to associations between each of the indicators and any outcome. If we were to say for a binary outcome, compare the average value of an indicator for those with the outcome versus without the outcome, and we divide by the factor loading, we need to get that same value as we'd have for any other indicator relationship between the outcome and the expected value of indicator I divided by its factor loading. So these are empirically testable implications, again, even though we don't actually observe eta. And so we can use this to develop an empirical test to potentially reject the structural interpretation of a latent factor model. And there may be better ways to do this, but this is what we've come up with thus far. So suppose we have a discrete variable z. Again, you could think of this as a treatment, or you could think of this as an outcome where we're looking at associations between the indicators and the outcome. But the following two statements are equivalent for any values I and j and any value z. Lambda I times the expected value of j given z is equal to the lambda j times the expected value of xi given z takes on that value. That was the empirical implication of having a structural latent variable. And that turns out to be equivalent to the model for the expected value of xi given z being expressible as a product of alpha I and beta z. So we're kind of imposing restrictions effectively on the form that expectation can take. And so then what we can do as a statistical test to potentially reject a structural interpretation of a latent variable is we can compare that constrained model for the expectation of xi given z, involving a product of one parameter for each indicator and one parameter for each level of z, to an unconstrained model where we in fact have separate parameters for every joint combination of the indicator and the value of z. So the first model imposes no restrictions. The second model are the restrictions imposed by the structural latent variable. And this allows us then to construct, in principle, a likelihood ratio test where we compare the residual mean squared error under the restricted model, where the expectation needs to conform to that product of the two parameters versus an unrestricted model. And by standard likelihood theory, that likelihood ratio test statistic will be chi-squared with parameters n-1 times p-1, where n-1 is the number of indicators, and n is the number of indicators and p is the number of values of z. So we can construct a likelihood ratio test and see, is that restriction of the model parameters that's imposed by a structural latent variable reasonable? And so we've applied this to one of the most widely used scales, or probably the most widely used scale in all of the well-being literature, Ed Diener's satisfaction with life scale. It has over 33,000 citations. I actually really like this scale. I still think it's one of the best, if not the best, life satisfaction scale out there, but it has 5 items, each scored 1 through 7, strongly disagree to strongly agree. In most ways, my life is close to ideal. The conditions of my life are excellent. I'm satisfied with my life. So if I've gotten the most important things I want in life, if I could live my life over, I would change almost nothing. Prior work reporting supposedly good psychometric properties, convex else is high, single factor seems to explain a considerable portion of the variance across item responses, again, used in thousands and thousands of papers. And so, we kind of came across this somewhat accidentally, but we were doing work published last year looking at associations between satisfaction with life and all-cause mortality 4 years later using health and retirement study data, about 13,000 individuals, mean age 66 upon entry, looking at kind of tertiles of life satisfaction in 2010 with mortality 4 years later, controlling for a host of social, demographic, economic, health-related, psychological, personality factors. And if you compare the top tertile to the bottom tertile life satisfaction, those in the top tertile had a hazard ratio of 0.74, so about 26% less likely to die during the 4 years of follow-up than the bottom tertile. So some evidence for an effect of life satisfaction on all-cause mortality. But we also, in sort of the supplement, looked at what would happen if we examined these associations indicator by indicator. And the results look somewhat different. I mean, for some of the indicators, you get almost exactly the same thing. In most ways, my life is close to ideal. The conditions of my life are excellent. I'm satisfied with my life. The ratio, the hazard ratio is really, really very similar. A little bit different. So far, I've gotten the most important things I want in life. But one of the indicators just had no association whatsoever with all-cause mortality. If I could live my life over, I would change almost nothing. Sort of having no regrets just has no relation with all-cause mortality in this data. And that was the case actually with a number of other subsequent outcomes as well. Now, if there's intuitively, if there's a single latent structural variable that explains all 5 of these indicators, we should not be observing patterns like this. It just can't be the case that one of them is totally unassociated with the outcome. And sure enough, if you carry out the more formal statistical test for the assumption of a single univariate underlying structural latent variable, we have 5 indicators, and our outcome is just death or not, so two levels. So we end up with a chi-squared test statistic with 4 degrees of freedom, chi-star test statistic itself of 67, really strong evidence against the null of there being a univariate structural latent variable, p of 8 times 10 to the minus 14. I think it's fairly safe to say, and again, the intuitive evidence is really looking at the associations of the indicators one at a time, but it seems like there's strong evidence against there being an underlying univariate latent life satisfaction that gives rise to these indicators and is structural. Now, this doesn't mean that satisfaction with life is a bad scale. I mean, it could be very reasonable summary outcome of different aspects, different facets of satisfaction with life. What it does mean is that there really is no univariate underlying latent construct that gives rise to these indicators that's causally related to other outcomes. We can pretty confidently reject that. So I think our reliance on a univariate underlying latent structural variable has probably often obscured relevant causal distinctions. Again, there's nothing that in a univariate factor model, even if there's a factor that does give rise to our indicators, there's nothing in that model that means that it may be the case that for a particular outcome, only one of the indicators has any causal effect. Or that the underlying factor gives rise to others, which themselves gives rise to indicators, but that only one of them is really causally relevant for the outcome. Nothing in a factor analysis model suggests that this might not be the case. It's a leap from, a single factor fits the covariance structure well, to, all of the indicators are causally relevant for the outcome, or that only that latent variable is causally relevant, that the latent variable itself is structural. There's a leap that takes place that's often not acknowledged. And again, I think has led to our missing important causal distinctions. So I think evidence for there being a structural factor really needs to be established, like through these tests or something else, not presumed. And I think without such evidence, these indicator by indicator analyses may be preferable. Moreover, I think if the factor is not structural, then it really obscures what might be taking place in factor analysis. The underlying latent is not structural, then an intervention that affects 2 of the 5 indicators, say, would in fact itself change the factor structure. So I really think we need to be more careful in the interpretation of factor analyses, in that jump from there being a single statistical factor to there being a structural factor. I think most psychosocial constructs really are inherently multidimensional. So I've focused more on this reflective model, the latent giving rise to indicators, but I think the same issues arise with formative models or things that are often viewed as an index, like social integration. So as another example where things have perhaps been obscured, this is data from a paper in 2017, Chang and co-authors using nurses' health study data, looking at a measure of social integration based on the Berkman-Syme index in 1992, and the associations between that and incident coronary heart disease over the next 22 years. And their social integration index is formed by a number of indicators: number of close friends, community group participation, religious service attendance, marital status. And I think each of these is scored 0 to 3 and then summed. And these analyses adjust for age, education, census tract income, variety of health conditions. They compared low versus high social integration, and those with high social integration, lower hazard of coronary heart disease, hazard ratio of 0.78, confidence interval 0.7 to 0.88. But again, we're combining here a bunch of relatively heterogeneous social exposures. And so, what happens when we look at these one by one? Well, it turns out they did that analyses, and with religious service attendance, for those attending more than once a week, you get a comparable hazard 0.82, confidence interval 0.7 to 0.9. For other community group participation, number of close friends, really not much association at all. Marital status, possibly. Confidence interval a bit wide, so difficult to have definitive conclusions here. But combining these really seems to obscure what's going on. A lot of this really does seem to be driven, in fact, by religious service attendance. And these analyses here are looking at the indicators one at a time, but the authors report that similar results were obtained when each of them were mutually adjusted for the others. And other work that we've carried out, I was not involved in any way in this study here, but we've found something very similar with regard to suicide, where really it's religious service attendance that's predicting lower suicide rates and not much association with any of the other social involvement indicators. Whether it's coded continuously or dichotomously also doesn't seem to matter. And similarly with mortality, all-cause mortality, most of the association driven by religious service attendance, some with mortality by marital status as well. So again, by just collapsing to a single index, we're obscuring different causal associations. So, I mean, why do we always assume a unidimensional construct? And I'm still kind of puzzling over it, these questions, but I think some of it's obviously statistically appealing. It makes analysis easier. It has become standard practice. I mean, we talk about depression or well-being or social integration, and then we assume, we just use a single measure. It also does correspond to traditional reflective and formative models. Many factor analyses seem to indicate that the covariance structure can be explained by a single factor. But then some of it is we don't really examine the relevant evidence for whether that factor really is structural. And I think we need to start doing so. I think another complicated issue here is that while factor analyses often seem to indicate at least a unidimensional covariance structure, these factor analyses don't really help us to distinguish what happens if we had two factors that were themselves causally related to one another. I've sort of ceased believing in factors, or at least structural factors, but for the sake of argument, I'm going to say, let's suppose we did have two factors, but they were causally related to one another. What happens then? Because I do think this is part of the story, part of why we always come back to wanting to use univariate measures. And so as examples, like maybe we have two different constructs, anxiety and depression, and maybe we have factors corresponding to them, but what happens if anxiety itself causes depression? Or being depressed, focusing on what's negative, gives rise to greater anxiety. What happens to our factor analyses then? So for the sake of argument, I'm going to assume that we have a series of indicators, Y1 through YP, and two factors, and the indicators load completely separately on the two factors. Again, you can think of these as factor one being depression, factor two being anxiety. But let's suppose that we're making assessments over time, and that there are potentially causal relationships between the two. That the two factors, either at time t, are causally related to those at time t minus 1. That depression might cause anxiety, anxiety might cause depression. So this gets a bit technical. I won't go through all the details, but under this sort of model where the factors at time t are causally affected by the factors at time t minus 1, if the random error terms in that causal process decay sufficiently quickly so that we do eventually get convergence in distribution of the indicators themselves, so that process does eventually converge to a factor model as time goes to infinity, then one can show that the dimensionality of the process as it converges, we'll define eta star as that limit, the dimensionality, the rank of that limit is well, it's a bit complicated, but the rank of that of the factor model as t goes to infinity is as the rank of d star, where d star is defined as the limit of d, and d is the matrix in the Jordan decomposition of B, where B was our matrix causally relating the factors to. There's a bit of argument here, but and then know that for factors, things do become more complicated with multiple factors. But if we start with two factors, then the dimension of either factors in the in the final factor model, if and only if B is the identity matrix. In other words, if and only if no causal effects from factor 1 to factor 2 or factor 2 to factor 1. The only way to have that process converge to a factor model with two factors is for there to be no causal effects. If factor 1 affects factor 2 or factor 2 affects factor 1, then as that process converges over time, it will look like there's only one factor. So even if it's the case that in a given wave, conditional on the past, the items completely load independently on two separate factors, if it is the case that one factor causally affects the other, then equilibrium, an exploratory factor analysis with one way, it would indicate that a single factor would be sufficient to explain the covariance structure. So really, if we're doing factor analyses with a single wave of data and we end up with one factor, we don't really know whether it's the case that a single factor really is sufficient to explain the covariance structure, or if it might be the case that there are causal effects we have two factors and there are causal effects of one another. We really have no way of distinguishing these possibilities. And so I think many prior factor analyses may need revisiting. As an example of this, here's a factor analysis looking at a bunch of depression and anxiety items. After carrying out factor analysis, they conclude psychologists believe that anxiety and depression self-report skills have different constructs. This assumption by confirmatory factor analysis on mood data on clinical samples and the clinical sample, these analyses provide evidence that anxiety and depression report skills do not measure discriminant mood effects and may therefore be thought of as measures of general negative mood than as measures of anxiety and depression per se. Here's another study, same question, 28 samples, a meta-analysis of factor analysis, but same general conclusion. Due to the presence of a strong general factor, the data does not provide good separation between symptoms of anxiety and depression. We recommend it is best used as a measure of general distress. I think the notion that anxiety and depression really, in fact, are the same construct, psychological distress, is nonsense. The emotions underlying, fundamental emotions underlying depression and anxiety are different. Sadness and fear are not the same thing. I think what's going on is really these factor analyses are uncovering what in fact are strong causal relations. There's considerable evidence from meta-analyses of longitudinal studies that anxiety causally gives rise to depression, depression causally gives rise to anxiety. And so I think these causal relations are obscuring what we obtain in factor analyses. So I think factor analyses, which indicate a univariate covariance structure, in the presence of potential causal effects, really don't allow you to say anything at all. So, I mean, what's clear from the causal inference literature, and I think what needs to be more clear in the measurement literature, is that we need to distinguish between causal and conceptual relationships, between causation and association. So, in a lot of the causal inference literature and biomedical and social sciences, we're concerned about what one might call the causal fallacy, concerned about the fallacy that correlation implies causation. We try to articulate the assumptions under which we can make that move, but then we're very cautious about the assumptions themselves. I think a similar fallacy, though in the reverse directions present in the measurement literature, we might call this the measurement fallacy, that correlation never implies causation. It always indicates a conceptual relationship. And I think this too is incorrect. Yes, it might indicate a conceptual relationship, but correlations can also arise from genuine causal relationships. And I think that's what's taking place with regard to depression and anxiety. So I think this measurement fallacy is perhaps at least as problematic as the causal fallacy. I mean, we kind of know that good measurement's needed for good causal inference, but I think it's also the case that good causal inference is needed for good measurement. I think it really does work in both directions. So kind of big picture implications of all of this, I think evidence for univariate covariance structure doesn't mean that there's a single univariate underlying construct. It can be obscured by causal relations. Even the absence of those causal relations, a single statistical factor doesn't necessarily mean those indicators are differently causally associated with outcomes. I think in most cases, psychosocial constructs are pretty much always multivariate. And I think we don't see this because of current factor analysis practices and because we don't look at the relevant evidence sufficiently often. So how should we proceed? Well, I'm going to sketch my current thinking on this. They're kind of drawing on theory for multiple versions of treatment. Causal inference under multiple versions of treatment. So this work was carried out nearly 10 years ago for looking at things like taking obesity as an exposure, and what does that really mean if we're looking at the effects of obesity on mortality? There are different ways to change BMI. We could imagine dieting or surgery or liposuction, and how do we interpret these associations when a given exposure could arise from a number of different potential interventions? And so in this more recent work, generalized this to allow for psychosocial measurement. The original theory kind of required deterministic relationship between the underlying versions of treatment and our treatment measurement. But it can be generalized and weakened to just an independence assumption, which then makes it applicable in the context of psychosocial measures. So we're going to assume that there's a latent multivariate versions of treatment variable K, kind of corresponding to our eta. But eta is now, not univariate, and it might be highly multidimensional, thousands of dimensions. We're not making any assumptions as to the dimensionality of eta, but it does give rise, eta gives rise to our indicators x1 through xn. We then form some sort of constructed measure from those indicators, and often we just take the mean. L will be some set of measured covariates, Y will be our outcome, YK the potential outcome if that versions of treatment variable, the underlying phenomena, had been level K. And kind of the fundamental assumption here is that Y, our outcome, is independent of our measure that we formed from the indicators, conditional on our covariates and the true eta or K, the actual process giving rise to these effects, which we don't really necessarily know about. We're going to assume that L our covariates suffice to control for confounding of the effect of the latent process K eta on the outcome, and also that the technical consistency is for K for the versions of treatment variable. One can then show that under those assumptions that the covariates L control for confounding of the underlying process or multiple versions of treatment K, if we were to just carry out a standard analysis where we use our, this could be done via regression, but where we use our measure A formed by the indicators and adjust for those covariates L and compare two different levels of treatment. I mean, this could be with satisfaction life scale, this could be comparing 15 to 20. If we just do that, then it can be interpreted, that observed association can be interpreted as follows. It can be interpreted by this causal expression here, where we're making reference now to the effects of the underlying process, K or eta. And sort of it's a standardized causal effect where we're standardizing by the distribution of the versions of treatment, comparing satisfaction with life values 20 versus the distribution of the versions of treatment amongst those with satisfaction with life value of 15. So kind of the way one can think about this is it could be what we obtain from our regression analysis, where we just regress our outcome on our satisfaction with life scale measure adjusted for covariates. We can interpret that as follows. It would be a comparison in a randomized trial in which within strata of our measured covariates L, each arm is randomized to a version of treatment K from the overall distribution of K in the population, those processes giving rise to satisfaction with life, amongst those with satisfaction of life scale value 20 versus the distribution of K amongst those with satisfaction of life value 15. So you can think of all the different ways that one might get to a satisfaction of life value of 20 versus 15. And then for each individual, we in each of the arms, we randomize either to one of those versions of treatment, the processes that give rise to a satisfaction of life value of 20 versus of 15. We do that for every individual, and we compare the overall outcomes, let's say on mortality, under these two different randomization schemes. So it's a bit of a diluted interpretation, but again, it's always making reference to that underlying process giving rise to our indicators. So there are real challenges in this interpretation, which I don't want to sweep under the carpet. If we don't know the versions of treatment, if we don't know everything giving rise to satisfaction with life, then our interpretation is somewhat ambiguous. What is that overall distribution of trajectories to get to satisfaction of life value of 20 versus 15? We certainly have no way of implementing such a randomized trial or intervention in practice. If we don't know that underlying process, the versions of treatment, it's difficult to assess the no confounding assumptions, and the interpretation of what constitutes a version can vary depending on what we've adjusted for amongst the measured covariates. But what I would argue is that with psychosocial constructs, we have no objective reality that we can define or are dealing with, where everything is just a set of indicators. I think this is the best that we can in fact do. And I think awareness of these limitations, of these challenges in interpretation, ultimately help us with interpretation itself. It makes us more humble, and it makes us realize that when we talk about the effects of something like life satisfaction or depression, for example, what we're really getting at is a very complex set of phenomena, the effect of that on mortality, and that phenomena as reflected by the indicators we in fact have. So this is kind of like a reflective model, but that underlying latent is not univariate. It is multidimensional, unknown, and complex. If we did have a reflective factor model, the interpretation with the univariate latent, the interpretation would still hold. But we're not presupposing that univariate structure in this case. It's applicable even without that univariate structure. So we can proceed if we want with a univariate measure, but again, it does obscure somewhat what's driving the effects, as was the case with the satisfaction of life scale or social integration analyses. Moreover, if what's causally relevant, maybe if only one of the indicators is causally relevant, if that in particular indicator happened to be rare, we might well just miss the effects entirely. In perhaps more unusual cases, if the causally relevant indicator was in fact inversely correlated with the entire with the other indicators, that would be unusual. But let's say if religious service attendance were inversely correlated with all of the others, you could actually get the direction of the effects wrong as well if you just use a univariate measure. Also, if we just use a univariate measure, it doesn't really provide guidance on where to intervene if our indicators are potentially subject to different sorts of intervention. So I think often it will be better when data allow. You need much larger sample sizes, but when data allow, to do indicator by indicator analyses. So kind of what I'm putting forward is a new potential model of measurement, which again shares similarities with both reflective and formative models, is that we've got some complex underlying reality giving rise to phenomena related to our construct. Those phenomena give rise to the series of indicators we measure, and then we form some sort of measure, often by averages, but we could do weighting or whatnot. But it's really that those underlying processes that are giving rise to our outcomes. That same underlying reality gives rise to the concepts through the language we use in communities, and then that gives rise to the constructs which we define or specify to try to operationalize our thoughts and ideas to something that can actually be discussed and used in empirical analyses. But importantly, those processes giving rise to our indicators, I think with regard to psychosocial measurement, are always multi-dimensional. So this multiple versions of treatment theory, I think, gives kind of a radical freedom. One can use whatever indicators one wants. One can form whatever measure one wants. Or one can use the indicators one at a time if one wants. It does obscure the interpretation, because exactly what is in either, what is really part of the process. But we can effectively, with the multiple versions of treatment theory, use whatever measures we want. And I think those decisions really need to be made more on conceptual grounds, not on statistical or empirical grounds. So what goes into the measure, we should be deciding a priori based on what we care about and whether we think these indicators really are related to our constructs. I think there needs to be much more clarity between the constructs and the items we're using. I think there needs to be much more clarity with regard to our definition of the constructs themselves, and whether the items are intended to be necessary and sufficient conditions for the construct of interest, or just necessary, just sufficient, or just illustrative. I think there's a lot more logical conceptual work that actually needs to take place within measurement work. Because again, I think in principle, we can define the measures however we like. But what's important then is the measures that we use correspond to the constructs we're interested in. And I think that's a conceptual, not an empirical question. So big picture, I've tried to challenge the notion that there's, in most cases, a single univariate underlying latent construct. I think that assumption that there is and that it's structural is strong. Moreover, it's empirically testable, and I think generally implausible. I think it's often presumed and not evaluated. I think most psychosocial constructs really are inherently multidimensional, and I think potential causal relationships also make supposed factor discovery really very challenging, because associations can reflect conceptual relations, but they can also reflect causal relations. So I think factor analysis can still be helpful and interesting, help identify groups of strongly associated indicators. But we still have to ask the question, why are these correlations arising? Is this because of causal relations or conceptual relations? Well, factor analysis doesn't give us that. That gives us associations, but we need to interpret those associations. Again, with multiple versions of treatment theory, we can still use univariate measures, but that has the potential to obscure effects, to fail to identify causes, potentially even getting things in the wrong direction, and it fails to guide intervention. So I think when data allow, and again, that won't always be the case, but when data allow, I think indicator by indicator analyses for causal inference are better, are more appropriate. And I think we need further measure development work, better, more careful mapping between our constructs and the items and measures we use. And we really do need better interaction in the measurement world with the analytic philosophy literature, which has tried to both provide precise definitions of various constructs, but I think also the logical relations between the items and the constructs would become more clear and help inform the selection of items. So I'll stop there. Thank you all for listening. I know it was a lot, but happy to take comments or questions.
Thank you, Tyler. That was a very stimulating talk. I'm sure there's plenty of questions, and we have time for a couple. I have my own questions, but I'm not going to be selfish. I can always email you later. So why don't we open the floor? If you would maybe like to, I'm not sure I can see everybody.
I could also stop share and then pull it up as needed.
Okay. All right. Let's see. So if you want to maybe place a question in the chat or raise your hand, I'll scroll to see if there's anyone. Or you can just jump in, I suppose. There are no questions?
You're welcome to fire away, John.
Okay, so I have in your critiques of the formative and reflective models, have you allowed for the possibility of interaction and background factors that could either interact with the latent to produce the indicator or interact with the indicators to produce the outcome? And could this be like a more flexible univariate model where there is like this univariate structure, but it behaves differently in different circumstances? And like, could that explain some of what you're seeing? And maybe is there ways to expand what's been done with factor analyses, or does it still lead you to sort of your same conclusions?
Yeah, no, that's a good question. The test that was proposed could be, we don't have it in the paper at present, but could be extended to allow for different associations across different subgroups. So that would be feasible. I think a further critique of the test we proposed is what happens if the relations between the factor and the indicators are themselves nonlinear. And right now the test we have assumes that linear structure. I think it could be potentially generalized further. It would be the statistical inference would be more complicated, but I think in principle that could be done as well. So I mean, in some ways, the test is really just illustrative of what I think is wrong. I don't think these tests provide definitive conclusions because of the possibility of interactions or of nonlinearities. I think my position that psychosocial phenomena are always multivariate, really more conceptual than empirical. What I have tried to do is I've tried to say, if we use the models which are typically employed in this literature, we get strong evidence that these factors are not structural.
Thank you very much. Any other questions? This is usually a very active group.
We're in a state of shock.
So I had another question. Is the title of your talk is psychosocial constructs, right? So it doesn't seem that it would be that great of a leap to think about the critiques that you proposed for, say, measures of social phenomena or, organizational sort of climate or behavior, things that maybe exist out of the mind and out of the individual, that are more at a collective level? Are there critiques that the arguments that you're raising applicable to those sorts of measures as well?
Yeah, so I mean, the original multiple versions of treatment theory proposed were more for settings, I think, where there are objectively definable phenomena, but where we collapse anyway. And I think a similar approach, but similar challenges to interpretation arise. What I think is unique about and what differentiates psychosocial phenomena is that there's really no way, to my mind, around it. I think the very constructs themselves arise from our language and our communities, and don't have an objective status beyond that. And so they're always reflecting I think intractably complex processes that are reflective of the way that language itself has emerged in culture. So I think we're just with social and psychological constructs. I think they're extremely important, and I think they have profound effects on health. But I don't think there's any way around the complexity and the processes giving rise to these phenomena.
Sure. We have time for one more question. I think
I'm happy to stick around a few more minutes.
Okay. So now everyone has questions.
I
think Liz and then maybe Scott. So Liz, do you want to ask yours? You had your hand up for a while.
Thank you. It's not super well articulated, but I guess, Tyler, what I'm thinking about, and I'm trying to, you sort of touched on this here and there, but I'm hoping you can expand a little. Like, not all analyses are causal. This is a causal group, but sometimes we're interested in just associations or description or prediction. Could you talk more about sort of the implications of this for these sort of different sorts of studies someone might be doing? And sort of, anyway, that's what I'm sort of trying to grapple with. It's like you sort of implied causal structure underlying things, but we don't always care about the causal structure.
Yeah, it's a good question. I mean, but very crude answer, not well developed, would be, I think in that setting, it's whatever is most useful, whatever gives you the best predictions, and that might be a univariate summary. I mean, even there, and I've not developed this yet, but even there, I think if that's the case, then one might be better off with like principal components analysis rather than factor analysis. Because I mean, factor analysis is sort of assuming there is some sort of real univariate latent, and you're trying to get rid of the measurement error in the indicators. Principal components is trying to reflect what's unique to each of the indicators as well. So I mean, again, I haven't developed this yet, but it's something I do want to do deeper thinking about. If we're abandoning the kind of structural univariate latent, what are the reasons for doing factor analysis versus principal components analysis when we're trying to kind of maximally extract information?
Thank you. I think Leon was next, and then Scott.
Hi, Dr. VanderWeele. Wonderful talk. Now, this may seem like a cheap critique, but I note that one of your examples took a construct, social support, and said, well, what's really important is religious service attendance. But that itself is a construct which can be measured in a lot of ways. Like a Shaker meeting is probably different from like daily mass or something like that. And so, without just making this a cheap critique and saying, oh well, everything's a bit of a construct. Do you have a sense in that example of why religious service attendance is sort of better than social support, or sort of gives more insight, or is in some sense a finer, more specific construct? Do you have any thoughts on that?
Yeah, I mean, there's some discussion of this in the paper that, that itself is a indicator for a very complex underlying phenomena. And so you with the multiple versions of treatment theory, you kind of have a multi-stage randomized trial. With regard to the more substantive aspect rather than methodologic of your question, this is somewhat more speculative, though I can point to some indirect evidence. I think it is the coming together of the kind of understanding systems of meaning values with the social that's giving service attendants or religious communities its power. You don't find the similar strong associations with private religious or spiritual practices. It's weak. I'd say it's weaker than other forms of community participation. But you find larger effects with religious community than you do with other forms of community engagement. So I think it's kind of the coming together of the values, the ideas, the purposes, the understanding with the social that's really giving rise to these effects. That's a bit speculative. I mean, I can point to some empirical data suggestive of this, but that's my sense.
Thank you.
Scott, you have the last question.
Great. I also want to join the others in thanking you for an excellent presentation. Really, really stimulating. I guess I wonder where we should be looking in terms of social phenomena. In the physics world, the eta in your graph, there's a rich theory, mathematical theory about the underlying constructs and how the multi-dimensions interact with each other, how minimal numbers of dimensions are needed in order to explain observable phenomena. And I guess, are you really saying that in the end we need to be moving towards a more mathematical and perhaps statistical theory about eta itself, the underlying constructs, when we want to make causal inference? I agree with Liz that there are many problems where it's probably not necessary, but so is the next step really to begin to move to talk about what those etas look like, what their dimensionality is, how they relate to the measurements and like?
Yeah, I mean, again, this work is still in more preliminary form and under development, but yeah, I mean, a few comments. One, I mean, I do think the crude analyses which we're doing with these scales are worthwhile. I think they're uncovering that there's something there to be studied. There's something with satisfaction with life that's important. For all-cause mortality, after controlling for a host of other things. But then I think the next step is, well, what is it? And it turns out eliminating regrets in life wouldn't help very much, at least suggested by these analyses. Maybe finding deeper contentment, ways of interpreting what's been good in life, even amongst its bumps, would be helpful. But even those indicators themselves are only giving clues to something yet deeper still. And so I think it's a matter of how much data do we have to be able to draw these fine distinctions. Okay, we can do so with a sample size of 13,000. But if we had a sample size of 1,000, no. And there we just rely on our single univariate measurement, and that's kind of giving clues as to what might be deeper. So I think you could view this as a multi-stage process in terms of trying to uncover what's most relevant about eta, about those underlying processes. But then I think another stage would be, when is it reasonable, in fact, to collapse? When, maybe with those three indicators, we're observing consistent associations between them, and not just all-cause mortality, but all of our other outcomes as well. And so maybe in those situations, it really is, so far as we can tell, reasonable to collapse. So I think further work needs to be done on when is it or is it not reasonable to do that collapsing, and for what purposes as well. So those are some of the directions that I hope to move in, but a lot more to be done.
Well, thank you, Tyler. This has been a very stimulating talk and discussion. I'm sure there's a lot more interesting work to be done, and you've done a great job in bringing a diverse group of people together to think about these things. So we just want to really thank you again for taking the time and presenting your very interesting work with us. Give a virtual hand clap and applause. And thank you very much.
Thank you all. Pleasure being here, and thank you for the fine questions. And feel free to send on any further thoughts. And wish you all the best in 2020.